The solids of revolution are solids that are generated when rotating a flat region around a certain axis. If we rotate a region like a triangle around an axis, we will obtain a solid of revolution, that in the case of the triangle will be a cone. To obtain the volume of these solids, it is necessary to divide it into disks that eventually add up and give a volume that approximates that of the solid. These disks are delimited by certain limits that are established according to the case. Normally, the solid is graphed to know how many disks it is necessary to divide it and also to see the limits. The formula to obtain the volume of the disks is the integral with limits a/b of p radius squared, where the radius is the function.
Our goal was to obtain the volume of this 600 milliliters bottle. To achieve this, we had to follow certain steps. First of all, we put the image of the bottle in GeoGebra, putting the end of the lid centered on the origin. And we also placed the image with the scale of 1 centimeter equals 1 GeoGebra box. This with the purpose of dividing the bottle in half with the x-axis and thus be able to extract the functions for the solid of revolution. To get these functions, we had to place several points by the perimeter of the bottle in GeoGebra. Having these points, we saw how many functions it would be convenient to obtain and then to establish our limits with the help of GeoGebra and obtain the functions in Excel. In our case, we decided to use 1 linear and 3 quadratic functions.
Having our function and limits already established, the last thing that was left to do was to take out the volume. To explain it, we're going to rely on the blue function. First of all, we substitute the function and the limits in the formula, where then we solve the function, square and multiply this result by pi. Afterward, we integrate this function that we obtain. Then, we evaluate the function with the limits and subtract the function evaluated with the greater limit, minus the function evaluated by the lower limit. Obtaining these results, we change only the unit of measure from centimeters squared to millimeters, since these units are equivalent. This was the procedure that we used in the 4 functions, which in the end, adding their result in millimeters, was what gave us the approximate result of the bottle.
The volume of the bottle that we obtain thanks to this technique of solids of revolution is 416.2808, while the volume of the bottle is 600 milliliters. The variation in the results is due to errors in the process of GeoGebra, decimals and small flaws in the shape of the bottle.